It's awesome. My work.
One of the girls that I tutor drives a 93 stick shift Toyota truck. Showed me a picture of it. I'm like, yeah. That is a beast right there, all 260,000 miles.
Well, that's good.
Delicious.
My computer's not switched on.
I don't know.
That is a vehicle right there. It'll get you where you need to go.
That's not good. Need to be charged. No.
No bells or whistles. Roll up windows with manual locks.
There are things that I wonder how long it's gonna grow while someone.
Yeah, right here.
Like forever.
So it's like, I'm not gonna have a computer to take this test.
Oh, the floppy disk?
Yeah.
Yeah.
Yeah. But the symbol like hang all down your window.
Oh, yeah, that's not, yeah.
Something so abusive.
Ellen DeGeneres got a little bit about that, like, how do you tell people to roll down your window? Like, even with the automatic, you still go,
Yeah, that's what I'm saying,
you
like,
can just go,
is that sign though, like, is that
that's gonna
hand
fade out.
gesture gonna, yeah, like
That's-
how long will that?
that's
gesture
already
be?
has, you do this.
Really?
I've seen that, I've seen that.
To me, that's just a point of referencing to your heat down below.
Yeah,
To
I
me,
guess all those people who I thought were insulting me were
Just trying to
passing roll
help
out the
you.
window, yeah.
Yeah.
Maybe I should have flipped them off.
I only know this from when I
Actually showing your
This is like, put down the window.
nice. Proud of you. That's good, man.
Yeah.
Hi, Adam.
Hi,
How you doing, buddy?
I'm reading.
Yeah, yeah, how's midterms?
Something this morning.
What?
It was like peasy easy. It's a window.
Okay, easy peasy.
100%.
Lemon squeeze.
Probably.
That's it?
I wish it was more.
You didn't write a Simpsons reference?
He gave us a Archer reference.
What?
He's asked us what Archer's mother's name is.
And Archer's middle name.
Mallory.
Yeah.
I don't watch Archer, so.
Sterling Mallory Archer, sir.
I don't watch cartoons.
Do you want ants? That's how you get
Why would
ants.
you put that on?
I remember making.
It's
There's
extra
a-
credit.
Yeah.
For
I
fun.
took it, he was all like Simpson references.
See, and I would have
I
done one
want
with
that.
those
I want
too.
extra credit that has something to do with.
It didn't.
I'll take a free meal.
I'm thinking, smells of like you throw hands.
Work to work, so like, well, just skip one, it would reset right away.
Yeah.
It would go from red to green. I would stop walking and then go to green.
Not wrong.
It's gonna ask how accurate it's at.
All right, good evening. How are you guys doing? You good? Good. Exam on Thursday, right? You read the instructions for the exam. So if you want to do it remotely, you're free to do it. Just need to maintain the camera on all the time. And the exam is going to be on Canvas. You're welcome to be in person, of course, and it's open books. You can look online, look for materials, slides, right? The only thing you cannot do is talk to each other or to someone else, okay? The review list, do you guys have a chance to look at the review list?
I thought it was really helpful. At first, I was overwhelmed. I'm like, oh Lord, there's how many pages of this? But I think it actually gave me a comprehensive what do I and don't I know. And I think that was actually really helpful.
Good.
It helps me, yeah, I think I'm gonna be able to focus my studying on what I actually don't understand.
Many of these questions in the review list, they were taken from previous exams and activities I like to do in class, previous semesters. Of course, you also have the quizzes, right? We had like 11 probably, or 12 quizzes. You can also use that as a resource as the exam. So, yeah, so around 7 questions, please. Make sure you have your Scala environment ready because you will be asked to write pieces of code. Okay. Of course, I'm not going to ask you to write, create a complete parser or anything like that, right? It has to be done in 2 hours, and I need to dose the questions. Make sure you have enough time to do it. So the focus for the coding questions will be on functional programming, okay? Because you can do those in short pieces of code. You can write really quick if you know what you're doing, right? Of course, if you don't know what you're doing, it takes longer. So the best way to prepare is to look at the questions. We had 2 lists, right, for functional programming questions. We just started the second one today. Maybe we can spend some time finishing that. We have time. Is there any specific question from the review list you want me to go through it?
Can you show us how you want us to actually write out your question 2? 2B. How do you want us to list?
Oh, the steps, right?
Yeah.
Okay. Question 3 also. I'm gonna go over question 2, question 3.
Then we just tempted to skip to the end.
Yeah. I have that question already answered, so let me just grab the answer. Okay, so you start the start symbol, the start variable, right, for this grammar is list. So you have to start with list.
You're gonna share your screen.
I'm not?
No.
Oh. List can be, one of the options for list is list comprehension, right? And because this is a list comprehension, we have to use this derivation here. From list, we're going to list comprehension. Excuse me. Is that me? Myself. List comp, and then you copy all this derivation here. Right? List comp is all that. And then you're going to expand. For example, let's start from left to right. So you have this expression variable, and you know you want to derivate I times j, right? So let's expand expression, and we know that we don't have expression here, right? Yeah, some variables are left underived, so I guess we can assume that from expression we can go to I times j. Okay, otherwise the grammar would be too large. So you can do this for the specific case. I guess you can go from expression to I times j. Then you repeat. So now let's say for clause, this variable for clause. Let's see what a for clause is. A for clause is for an identifier in a range expression. So let's copy all of that and replace with for clause with all this. Okay, and then we repeat the things we haven't derived yet. So now we have the for identifier. We can go to I, right, to match this. We have the in range expression. Range expression is range and then parentheses and a number. So we can do that. From range expression, we can do from to go to range, parentheses, number, parentheses, and the number we can go to 5. Okay, so you got the idea, right? So you just keep doing the derivations. One thing that I don't want you should avoid doing is skipping steps. Like, for example, going from list, then you do a lot of derivations in your head, and you get this. No, it doesn't work, okay? You need to show me some steps. Okay.
Could we also do a derivation tree? Would that work too?
It works.
Okay.
Right. All right, so questions like that, you have an understanding of what are the expectations. Just don't do super jump steps. Just show me progression, okay? All right, onliners. Okay. So next question 3. Same thing, right? Show the sequence of reductions. We grab that answer for you. Okay, some steps here. Take a look and see if you have any questions. I may put that in. Highlight this so you know it's the answer. So in order to do questions like that, make sure you review the symbols used in EBNF notation, right? So you just make sure you understand that the curly braces mean 0 or more times, right? the straight brackets means optional. Okay. And that's it, right? PBNF, we don't use epsilon because we have the curly braces and the brackets. Yeah.
We do question 11.
Question 1?
11, sorry.
Oh, 11.
And then, let's 101.
Another derivation, right? Oh, no, that's not a derivation. You basically, you need to
Just giving the rule, right?
yeah, the question is about based on all these things here, create a grammar, right? So a list can be empty, right? So the empty list is represented this way here. So that's why we have this production here. Then list can also be can be defined as a collection of items of a given type. So that's why we have this other option, containing brackets, right? The collection of items. What is an item? An item can be just one item. From items, we can derive one item or multiple items, right? Separated by comma. When we're done, we make items go to item. So we have a list of items here inside brackets. Another option is having a range, right? So list in Haskell can be built using enumerations like n dot dot m. That's this option here, item dot dot item. How do we get rid of all the suggestions here? See how to ignore them. Ignore.
Look at dots, is there an ignore all or something?
Here?
Maybe it's different.
In the menu, the mid right. I mean, the bottom right. Just give it like your normal customize suggestions.
Can't read that, David.
I've got a question about this derivation.
Okay, so this is the range, right? You can also have, you can omit the end of the range. That's this option here. It seems too complex. Let's just continue here. Okay. So as you can see, I was trying to do all the possible things described here to create lists, right? So there's this other option, infinite list. So you have the item and then dot dot. You can also have item, comma, item, dot dot, item. And a list can also be a list comprehension as an expression followed by a pipe symbol in one or more generators separated by commas. So this can be an expression and then next. The next is the generator. The expression is just it's not even define what an expression is. I think I mentioned something here. Variables you can use. So let's see what is a next. So next can be a generator. So you have just one generator, or you can have generator, comma, and this more. So more can be a generator, can be a Boolean expression, can be multiple generators, multiple Boolean expressions, right? Okay, so that's a way to formally define or express the syntax of Haskell's list construct. It wasn't clear here whether you should have expanded expression. I told the students during the exam that, okay, once you get your expression, you don't have to continue. I guess the same goes for Boolean expression. If this question was in an exam, I would make sure you understand that when to stop, right? Yeah.
So in this derivation, you're using items with the plural, but in the instructions, you say variables you can use, and it just says item, but there's no items. Is that something that we can create when we're going through that, or?
It was a mistake.
Okay.
Good catch. Yeah. I guess it's also missing the next, right?
Okay, and more, yeah.
Yeah, I guess more, you could have named something else, right? Doesn't have to
Right.
use more, right?
Right.
Well, do you need more? Can't you just use the braces, curly braces, right? So then you
No,
can say
because
something.
it's formal grammar notation.
Oh, okay.
It's not EBNF.
All right, good. That would got me.
And here it says variables you can use. It doesn't mean it's,
And that was my question, is if that meant that like, these are the variables you're allowed to use, or if it
it's
was
not
more
exclusive, right?
suggestions
You
of
can add
variables
more.
to use?
Yeah.
Okay,
So
okay,
I'll make sure it's more clear, okay?
okay, that helps.
let's go back and go sequentially now that we covered the most controversial questions, or do you have any other questions you want me to jump right into? Or onto? Yeah.
Well, did you do 13 and 14 for sure? That'd be changed.
Yay, everybody loves C.
So the area allocated by the C program, the one on the left, right? So you have an malloc, allocates enough space for 10 integers, returns the starting address of the allocated address. That information, that area is never free, right? So what are the consequences? You may run out of memory, right? So if you keep allocating memory, but you're not freeing the memory, you will end up exhausting all the memory resources available. The area allocated by the Java program is also never free. What are the consequences? Java is different, right? So Java, you're going to have a virtual machine that will take care of making sure that you have an object that does not have any references to it, the garbage collector that is managed by the virtual machine, the process controlled by the virtual machine, from time to time, it will make sure those areas are freed and available for others to use. Okay, so there are no consequences. You don't have to do, and you don't even have a way to do that. Java, in that sense, is in a much higher level compared to C. You don't have to worry about explicitly freeing memory. And then C, pointer variable data in the C program is assigned to an arbitrary memory address, right? This line here, that is being assigned this memory address. Do you think the program compiles? And if yes, what are the consequences, if any, of doing the assignment? Yes, the program compiles because the C programming language has this feature that allows a program to address using the concept that we discussed in class, pointers, right? Those are special variables, special types that allows us to create variables and assign arbitrary memory locations, just like we did in this example. So the program compiles. There are some risks when you do that, because it might be that your program does not have reading access to that memory location. So memory location might be, for example, allocated to another process, right? So it's not available for your program, or is a system protected memory. So there are consequences. Your program might crash because the operating system will detect that you're trying to access a memory address that your program is not allowed or not does not have permission to do it, and it simply will crash. The program will be terminated by the operating system. Safe mechanisms, right? And then we have the same attempt used on the Java program. Can you do that in Java? You cannot do that in Java, so the program will not compile. Okay. So what was the other one?
The next one.
Next one?
My first question would be the expression rule. How is that read? Is it you need an identifier, an operator, and then an identifier or number? Or is it everything to the left of the or grouped together?
Yeah, so in between the identifiers, you can have one of these operators. Okay, so basically you're trying to, with this, you're trying to express four constructions or four productions. Identifier plus identifier, identifier minus identifier, right? So all the four operations.
So those should be grouped together. My just thing is that or number is confusing me. Like, should there be parentheses?
Yeah,
around?
so this parenthesis here is part of the BNF that allows you to do a grouping. And this grouping will allow you to, with the pipes, to pick one of the operators. You can't have two operators at the same time. You have to pick one within that group. Okay.
The operators is fine, but we want to know, like, can you pick an identifier or a number, or is it only identifier, operator, and identifier?
Yeah, so this is one option that derivates to four productions, right? And there's this fifth. So an expression can also be a number.
Right.
Yeah, so this pipe here separates this production and this other one. So there are two options. This one here is actually expressing four different productions.
So then with that, according to the identifier production, you can't have like a plus a constant, like 5?
Identifier, the next one.
Yeah, because it has to be a letter followed by the.
You have to start with the letter, and after that, you can have letters or digits.
Wait, so then shouldn't there be parentheses around identifier
Zero,
number?
zero or more, right?
Yeah.
You can have just a letter or many, and then a letter followed by many letters or digits. So you guys are questioning whether we should have parentheses here, right?
Actually, what are those parentheses around identifier, the operator grouping, and the identifier?
Because this doesn't allow you to do like a plus 5, for instance.
Yes. A as an identifier plus, and no, identifier has to start with a letter. Can't do A plus 5. It has to start with a letter. Yeah, so the parentheses, you guys are questioning whether we should have parentheses here or not.
No, the line above, whether we should have parentheses around identifier, the grouping operator, and the other identifier. That whole thing should be in a parentheses.
This whole thing.
For that or, yeah.
I think so, because what is the alternation, right? Is the operator, right? So that's why we only have these parentheses. But you must have one operator, right? This one here, we don't put parentheses because the curly braces implicitly gives you the grouping, right? And it's kind of obvious that you pick letter or digit. Okay. So answering the questions here, is this, so this is a basic program, right? So a program has one or more lines. Each line has a number and a statement. So we need a number. So all the lines are numbered. Okay. And we have 1, 2, 3, 4, a number, and have one or more digits. Then we have statements. A statement can be one single statement and then followed optionally or one or more, so that a bunch of statements separated by the column. So we have here just a single statement. This is an example of multiple statements on a single line. A statement can, so this statement can be a let statement, a read statement, or a print statement. So this is obviously it's a let statement. A let statement has the keyword let, an identifier, equal, and an expression. Identifier, we know it's a letter followed by letters or digits. So this one looks fine, right? Let A equal 5. Expression. Expression can be a number, right? And a number is 5 is a number. So this is fine. Let B equal 10 is fine. All right. How about this one? Let C equals to A plus B. So this is the case when we have an expression, not a number. So this expression is an identifier plus another identifier. So we have A plus B. So that's correct. Then we have print C. So print, it continues here, identifier. So we want to print the value of C. So this is yes, this is good. All good. How about this one? Read identifier. And is it a problem that the lines are not sequentially? There's no problem, right? The grammar cannot check that. This would be more like a semantic error, right? Put a semantic rule that the line numbers should be numbers sequentially, but the grammar cannot check that through this syntax. So 10 read x1. Can I have x1 as an identifier? Yes, right? Letter followed by a digit. Read x2, let result. Result is also a valid identifier. Equals to this expression. Is this a valid expression? X1 divided by x2. It looks fine. Print results. Also looks fine. I would say it's a yes. Okay, so 1, 2, 3. Let x1 have multiple statements, right? Looks fine. Let z equals to x minus y. It looks fine. Don't you get nervous when you start seeing too many s's and no?
Yes.
I wrote the question and I'm nervous. Probably not seeing something here. Oh, okay. Fine, we're gonna have a no here. So let x, where is the equal, right? Yeah, we have a no, but it's not a balanced question. 3 yes and 1 no. I don't like that. Makes me wonder whether there's something. I guess this one here that didn't have the lines in the sequential order. It was made to, yeah, I should balance the yes or no, maybe this one is a no, right?
Lots of high school with the teacher grading exams, true, false, checkers.
Oh, that's crafty.
Skip to part C if you want. I don't think you need to do B. It's just more quantitative.
I'd like to see B.
C, you want to see? Oh, B? So let me copy B. I'm lazy. I'm still recovering from my marathon.
You need to see the photos.
Yeah, I have a, show you a picture of me suffering.
Suffering with.
B. I go ahead and also do C, right? So a program goes to, from program we go to lines, we need 2 lines, right? The first line, number and statements, but we only have 1 statement, right? So why am I doing 20 first? I guess I'm doing let A. It's kind of confusing because it's all,
Why don't we just do a tree? It's so much easier to look at.
yeah, I agree. It's really hard to read.
Saves you a lot of lines.
I'm just gonna leave for you guys to decipher.
Nice.
I was just curious, is that like defining both lines as line 20 in there? Because I don't see a 10 in any of that. I was just curious.
Yeah.
You did a bunch of steps in your head, didn't you?
Yes. Yeah, it's missing the 10. it makes it easier for you, you can do this. Put an observation and then do the derivation for the first line. So that's so what is a line again? Number and statements. Then number, you can go to 10. Then statements, you can just go to one statement, right? Then a statement is a let identifier equal expression. So let
Is this how you want it in the exam, or can we like put them all in new lines?
you can do copy and paste and put one at each line.
Oh.
Then let's identifier is a, right? Equal expression. We're almost there. Then let's a expression can be a number, right? I think we can go from expression to number, yes. Then we're able to do 10, let's a 5. Then you can do the other one, line is number statements. And 20 statements. 20, just one statement. And then 20, this is a print identifier. And then 20 prints a. Okay? I think it's a little bit more clear.
Yeah.
Now we want to rewrite using formal notation. Just identify all the variables, identify all the terminal symbols, starting symbol, and then you just need to break any EBNF simplification. You can rewrite in multiple productions like expression. We know it goes from to these 4 different productions, so you need to explicitly create one for each of the options. Yes.
Are we going to have to do something this tedious for the exam?
It is tedious, yeah. But I mean, it's still important, especially, for example, when you guys, when we're talking about the bottom-up parser, sometimes you need to express your grammar using a tool. You need to use a tool that does not support CBNF, so you need to translate to formal grammar notation so you can input the grammar into the tool, so you can build your parser. Okay?
That was a yes.
Yeah, but I mean, I will try to, if I have a question like that, I will try to make it, because we only have 2 hours, so I don't want you to focus too much time of the exam on this type of work. I just want to check if you know how to do it. I'll see if I can simplify and make it a very short exam.
Can you show C again? Or are you gonna post it?
It's already on there.
It's already on. more interesting questions that actually require your brains a little bit. Removing left recursion from a gram, right? This example here. You guys just need to also make sure you review that algorithm that we discussed in class to remove left recursion. This is also important when you want to build a top-down parser, a recursive descent parser. You can't have left recursive production, so you need to know how to remove them. Okay. Multiple choice questions. Read a stream of tokens, verifies whether it is syntactically valid according to programming language grammar. That's the parser, right? Or syntax analyzer.
Are those terms gonna be interchangeable on the exam?
I think so, yeah.
Okay.
Identifies the lexical units of the program and classify them to tokens. That's the lexical analyzer, right?
Yep.
Verifies rules that go beyond those defined by the grammar, scope rules, variables declare more than once, type checking. That's the semantic analyzer. We're gonna get question 15 soon. The only part of the compilation process that depends on the specific target platform, that's the code generator. Question 16 here. Can you identify how many tokens we have here? So this is the type, right? So I would say this is a token. This is also a token, right? Identifier. Equal. Also a token, right? Assignment. 15. Literal integer. Semicolon. Don't forget the semicolon. While, another reserved word. We have the opening parentheses. X1 is an identifier. Greater than an operator. 20 is another literal. So it's another integer literal, right? So let's say 10 and 11. And this is an identifier. Then we have plus plus as another operator. And semicolon. So 14 tokens.
Plus plus is just one.
Is that right?
Why is the plus plus 1 and not 2?
Because it counts as one, right? That's one operator, plus plus. It's the unary operator.
Would there not be like a end of file on this one? Would we assume there's no end of file token here?
Yeah, wouldn't it be wrong if you, at the end, you put 15 end of file, I would say it's okay. Because it's very specific according to the implementation, right?
Right.
But it's fine.
Actually, it's Java, so you can't have end of file right there.
Well, if it was Java, we.
Well,
Good, not write it after a while.
question 15, left recursion, right? So we need to remove A go to AXY, A go to Z. So how do we remove that recursion? So according to the algorithm, we should use Z A prime, right? Then we do A prime going to XY A prime or epsilon. Right, because here we try to produce as many XY as we want. When we're done, we need to make sure that A goes to Z. Here, we produce Z right away, and then we keep producing XYs until we are done. We're going to epsilon. When we're done, we remove A prime going to epsilon. Okay. Alejandro Rojas.
What does the C mean on CXY?
Those are terminals, and I guess C wasn't used there. Grammar is inconsistent.
It's supposed to be Z.
Ah, you're probably right. Good catch.
Could you write the G prime? Never mind.
Yeah, because you're rewriting the production, you have to rewrite the G set, right? Or you have to include A prime, right? But that will be another G because it's another grammar, right? But you just, I guess I understand what you're saying because the question asks rewrite the grammar as G prime. Let's do right way. Do G prime as A prime, XYZ, P. Let's call it P prime. And the starting symbol is still A. And then we can do P prime as this, right? And now it's looking very professional. Okay. Multiple choice questions about binding. Variable X is bound to a location in memory. That's correct. Variable X is associated to a value. Yes. is associated with the type. We expect that too, right? So A, B, and C are correct. What does the L value attribute of a variable refer to? So the L value is the location in memory. The R value is the value. The way you know that is just, you remember an assignment. The right side you have the value. On the left side you have the address where the variable is, the value will be stored. Type of binding that first occurs before runtime begins and remains unchanged throughout the program's execution, that's static. Type of scoping that depends on the order in which functions are called. Dynamic scoping, right? So don't expect questions like that, that I give you the code and ask you what's the output. Because you guys gonna have the IDE, so it will be just a matter of copying and executing and then copying the output. I know you guys are, you'll be mad if I do something like that, right?
So,
So let me test your brains a little bit. Don't let me do stuff like that. So the questions will be, you have the ability to run code, so I'll have to do something different. I ask you to actually write the code, right? I think, are there any questions in this list before we move to the function programming? I think we should also look at the activity that we started last time. Those are more likely to be in the exam. Of course, not exactly the same, but type of question. So we already answered question 13. We pretty much did all, right?
Yeah, I think we got everything.
Okay, so why don't we move to the activity functional programming set number 2. Don't forget to review the quizzes, okay? We have a lot of questions here that you can use in your review. So I think we did up until D, right? Why don't you guys work on E if you haven't yet? I graded the programming assignment project number 1. I'm halfway through finishing, so I will probably finish tomorrow. So.
Okay, yes, you're gonna call. Sometimes it's lag, right? Generate that list. Then
Okay, so for the prime factors. You guys able to do it? Prime factors? You create a range from 2 till n-1. You don't want to. So what you need to do, you need to test all the divisors, the potential divisors, and check if they are prime numbers, right?
So is it okay to filter your prime numbers first?
It's best to generate the divisors, right? Then you check if the divisors are prime, right?
Okay. Why is that better?
So how do you want to do?
It's quicker than
You want to generate the primes first? How are you going to generate the primes?
Oh, I see what you're saying.
How are you going to generate the primes, right? You need to start with a range and then you check if the number is a prime, right? Start with the shortest, like the most optimal start. Okay, so prime factors, this is one possible way to do it. Create a range 2 until n. Those are the possible. Those are the numbers you want to check. They can potentially divide n, right? But then we need to check if those numbers divide n, right? Because we can get a list of factors. This is what we get. Then we can continue that, right? Using filter to check if number in this list of factors evenly divide n, right? Does that make sense? Using filter now. So how do I write the expression here?
Then mod wildcard equals to 0.
N divided by the wildcard equal to 0. Right? That is the expression, right? The function that will check if this factor, this prime number is actually a factor of n and evenly divide n. Let's check that. I have prime factors of 40. And I got 2 and 5, right? Okay. So this is to give you a taste of functional programming. It's like you build your function in terms of other functions, and you try to reason in steps, right? So mentally, you did in kind of like a top-down approach with multiple refinements, right? That's an important software development strategy, and function programming kind of drives you to use this strategy, right? So you start with, okay, what do I need here? First, I need to get the factors, right? Factors are prime numbers that evenly divide the number. Well, I need to start with something, right? So let's start with the potential divisors of the number. So I'm going to just get a list from 2 to n minus 1, right? So those are the potential divisors. I'm excluding 1, of course, because 1 is not a prime number. So just get rid of that. And I'm also getting rid of n, right? Because I know n divides n, right? And it's not a factor. So I just well, if n is actually a prime, maybe we want to include n, right? Yeah. So let's see. Let's review that and put 2. Okay, 2 to n. Okay, so n it might be included. Okay. So those are the potential divisors, but I just want to keep the ones that are prime numbers. I already have a function that checks if a number is prime. I'm going to use is prime in the filter. So is prime is the function that's going to be used to filter this list of divisors. So now I have divisors that are prime numbers. And I'm going to check which of those prime numbers are actually divisors of n, or they're actually factors of n. By using filter again, this is how I'm going to check whether this prime number evenly divides n. Right? So the next one is prime factors modes. So I know that 2 and 5 are the factors of 40. But I know that I need to divide 40 by 2 3 times, right? Because 8 times 5 is 40, right? So I know that 2 is going to divide 3 times and 5 is going to divide 1 time. I want to know these exponents. So my suggestion is to create this other function called indiv. Given 2 numbers, a and b, this function returns how many times b evenly divides a. This function will be very helpful because it counts. For example, if I give a is 40 and b is 2, this function will return 3, which is the number of times b evenly divides 40. I'm using recursion here with better matching, which is another feature that is encouraged to be used in functional programming, as we discussed. So the matching is the remain of the division of a by b. If it's 0, it means b evenly divides a. I'm going to count 1. And I'm going to recursively call indiv, getting the division right, so a divided by b. And I'm going to keep doing this one more time, right? So for example, if I call indiv 40 and 2, right? So that's going to be even division. So I'm going to have 1 plus, and then I'm going to call indiv 40 divided by 2 is 20. That's in 2, right? 2 divides 20 evenly. So this call will also be return 1 plus indiv 10 now divided by 2, right? I'm going to keep doing that. Next call, I'm going to have, this is also an even division, 1 plus indiv 5 divided by 2, right? I already have 1, 2, 3. 5 divided by 2, it's not an even division. So it goes to the second case when I return 0. So this call here will return 0. So when the recursions return, the end that's going to be returned, the value finally returned by the first call is going to be 3, which is the number of times 2 divided 4. Think about using this function to compute to implement prime factors modes. Right? which function do you guys would be helpful based on the functions we discussed? The three tenors, right? We talked about map, filter, right? And fold. You think div will be plugged into which function? Filter, map, fold. What do you think? It's more like map, right? Got it. It's not filter because this function is not even a predicate function, right? So you can discard filter. Why is it map? Because what we have is 2 and 5. We do have OR, right? So what we need to do? We need to call map passing div 40 to 2. That will give us 3, right? And then 45, that will give us 1. Then we need to pair like 2 and div 42 is 3. 5 and div 45 is 1. So you basically you're giving the factorization of 40, right? In terms of tuples, a list of tuples. You guys want to put this together and share that later? Why don't you guys think about how you're going to put these all together? Prime's range is easy, right? Have the range. You just need to generate all the numbers within that range and call filter on each of those numbers because you only want the ones that are prime, right? So you can easily do that using 2 and a filter. Go back conjecture. Every positive even number greater than 2 is the sum of 2 prime numbers. 28, for example, is an even number greater than 2, and it's the sum of 5 and 23. It hasn't been proved. So if you prove that, you're more than a genius. You're amazing. But it has been numerically confirmed up to very large numbers. So you want to write the function that returns those prime numbers. So find the go back conjecture. Well, it's difficult to prove, but for the computers, it's very easy to find, right? Because they can test many until they find them. And with function programming, it's even easier because you can, using filter and those functions that we discussed, you can easily combine functions to do what needs to be done. So how about this? You guys finish that list, and by noon tomorrow, I will share that. Okay, so then you can check your answers. Okay. Yeah.
I'm not sure if I missed something, but I've been kind of doing this from scratch because I'm not able to find where this activity is posted.
Oh, no, it's
Is it a different
It should be in class activities.
Is it not on GitHub currently?
Oh, no.
Okay. No, I pulled up the activity, at the top it says get the code from GitHub and then I didn't have anything.
Oh, I'm sorry. Yeah, it does say from GitHub. How about this? I will create the GitHub and that's where I'm gonna post the solution, okay?
Perfect, thank you.
All right, guys, anything else? Good?
Nope.
See you guys on Thursday.
So excited.
Tomorrow I'll be grading in the morning, but feel free to text me. If you have any questions, okay?
How did your race go, by the way?
Oh, I forgot to show you the picture. Look at me, suffering. Look at this face. This is at the finish line.
That's pain in your
Hey,
face.
but you see, he's got the headband to catch the sweat, keep it out of his eyes.
That's so much pain.
That's smart.
You have the face that tells you even though it's over.
That's how a marathon feels like at the end. The beginning is more like this one. This is the one that I was actually.
Yeah, I think so. I know that he's, well.
This is how marathon looks like when you start.
He's talking about the activity just now.
That's not how it ends.
Nice.
You have a water bottle strap here?
Yeah, that was Gatorade.
They look like little grenades.
I take the opponent's out. Representing.
Anybody ever pass me through
Hydration grenades.
It was cool because they have these pacers. They run with the estimated time for the marathon, so they keep their pace. And then you see it's all like, this guy, if I keep running at his pace, I will finish at that time, right?
Oh, really?
It's really cool.
This is the triple we're talking about underneath the time factor.
That's it?
But
he was drafting people.
And then.
Let them break the.
Yeah, just let him lead for a while.
Well, I mean, if you let them break the air,
Yeah.
get that slipstream.
Yeah, actually I
What do
was
they call it?
copying
The
and pasting.
California.
Yeah.
Anything
It's like turning like ours.
Exactly.
Write to us and fill it out with all the information, so watch the slides.
Yeah, how dare we have.
Yeah, you have a couple minutes?
As far as I know, they constantly rotate this in front to keep, because the person in front is pedaling twice as hard as you're in. So they drop and they keep the cycle going, so nobody's in the
Have you
front
seen
for too
some of
long, and the whole
the?
team goes faster.
Have you seen some of the? There's several where they use like a rotor stator design for the.
Can you post one?
They use a brushless motor. Oh. They put it down to the crank state like.
It's gonna say that.
It sounds like cheating.
Yeah.
Okay,
So it's funny.
okay.
One guy went around the corner, he was like using it, he had a little extra battery juice and it was helping him pedal. He wiped out because of